For our extra credit video tutorial, we're going to be walking you guys through GaussView and Gaussian. So in order to start here, we're going to go down to the Start menu and type in GaussView. Okay, now that we're all set up here, we're going to start building. So the molecule that I'm going to build is DC07 from Lab 3. So to start off, we're going to open up this builder here, which is under View and then Builder. So you're going to select that, and this Builder panel is going to pop up. Okay, so to start off, you're going to double click this one, and that brings up all sorts of different shapes that are available. So I'm going to go with this one, and then use my scroll wheel to zoom out. You can also click and drag to rotate your molecule around. Okay, so starting off, I need to replace this atom with a oxygen. So I'll come up here to this element table and click it twice to bring up all these elements. And I'll select oxygen, and all we need is the atom here. So I will replace that and come up here to this delete atom function and delete the hydrogen off of there because we don't need that. Okay, and then we're gonna build this second ring off of the side of this. And the best way that I know how to do this, or at least the way that it'll show the most functions of GaussView, is to bring this up and do it carbon by carbon and then connect it at the end. So we're gonna click on these molecules that we want to replace, or these atoms that we want to replace, until we get our 6 bonds here. 1, 2, 3, 4, 5, 6. And we're going to delete our extra hydrogens. Oh, shouldn't have deleted that one, but I'll replace it. So over here to replace the hydrogen, I'm going to click here and add that hydrogen back. So now to combine these, or put a bond between these atoms, I'll come over here to this function and click both the atoms that I want to connect, and I will select a single bond and use this brush function to clean up the bond lengths. And now I'm going to use that same bond function to make the double bonds that I need for this benzene. Okay, and I'll clean it up again to make sure that everything looks good. And it does. So next I'm going to continue on with this molecule and add in a oxygen right at this position, and just to make things simple here, I'll put a hydrogen off of there and turn that into a carbon. Okay, and then I need another carbon here with a carbonyl coming off of it. So I will do that here, make that into a double bond, and get rid of one of these hydrogens. And clean it up and make sure that everything looks right. Yep. And then I need a nitrogen substituted ring. So I will come over here and add this nitrogen here and build my ring off of it. It's going to be a 5-membered ring. So there we go. I'll delete those extra hydrogens. Actually, there's no double bonds in this, so those are not extra hydrogens. So I'll add a few of those back. I do need to delete one from each of these in order to connect that bond. So that's done there. Okay, so we have our nitrogen substituted 5-membered ring. And now off the top of this one, we're going to have another group. So we'll add a carbon here. And then we need a water and a cyanide. So there is our water, and we need to make sure to get the stereochemistry right here. So the water should be pointing back, and the cyanide should be in the page. So that is going to be where we want our cyanide there. Okay. Delete those and add in an elemental nitrogen. Okay, and we need to go in and modify that bond to be a triple bond here. Now we're going to clean all that up. And then, most important step, we're going to double check and make sure that each atom has the right number of bonds, or else it won't optimize correctly in Gaussian. So I'll just go through left or right to left and make sure that all the atoms are correct, rotate it around so I can see easily. Okay, so now that we have the correct molecule for DC07, I'm going to come up here to File and save it as a GJF file, and we're going to save it to the desktop. And I'll just name it DC07. Okay, I'll save that there. Now we will come out to our desktop, and here it is, the DC07 GJF file, which we will open in Gaussian 09. So go to your start bar and type in Gaussian 09, and it'll pop up right here. Okay, so what we're going to do here is we're going to open our file, go to our desktop where we saved, and open our DC07 GJF file. Going to open it, and all of this stuff is going to pop up. So starting at this top one, we're going to delete all of this down to the percentage sign and replace it with mem equals 30 MW capitalized. Then this next one, we're going to delete all of this, but leave the pound sign and the space and type in AM1 opt free. And we're going to come down here. We're going to come down here and delete all of these extra numbers here. Okay. So the only thing left is all of these sequences. And the charge of this molecule is 0. So you're going to leave charge as 0. And then multiplicity has to do with the number of unpaired electrons, not lone pairs, but unpaired electrons, which for most of the molecules you're going to be dealing with is 0. And there's this formula that they'll probably go over in class, but if there's 0 unpaired electrons, then you're going to end up with a multiplicity of just 1. So usually it is 1 when you bring this up, but if it's not, you can just change it to 1. Yeah, so if there's any free radicals, then that'll change the multiplicity here. And with all these adjustments here, then we're set to run. And this is going to pop up for where we want to save it. And we will save it to our desktop. And it'll save as a DC07 out file. And this program is just going to crunch all the numbers for us. And we just kind of sit by and wait. After about 1 or 2 minutes, it's going to finish with the computation. It's going to give you a nice quote here. And if everything went well, it's going to say normal termination of Gaussian 09. So let's double check our work and open GaussView back up. And we'll go File, Open, and switch the type of file that we're opening to an out file and open that file that Gaussian saved. And let's see. Okay. Okay, it looks like it's saved properly. Basically, looks like the one big alteration that it made was evening out this ring and making it flat. So that's basically Gaussian and GaussView in a nutshell. Thank you for watching our video tutorial. Have a good day.